Hello, welcome to this video introducing Tableau Public. In this video, we'll run through some basics of Tableau Public, the visualization tool you'll be using to tell the data story using data from the Social Security Administration. Additional features will be covered in the exercise, but in this video, you'll load the data, take a tour of the Tableau interface, and do some minor configuration of your account. First, to tell a story, you need data. To get started, download the file named SSA statedata.zip from the module in Canvas. The file is large, so it's zipped up to speed up the download. This file contains data on the first names of every man and woman who applied for a Social Security card and was born between 1910 and last year. Pause the video, download the data, and then come back here when you're finished with the download. Okay, now that you have some data, let's dive in. As we walk through importing the data, follow along in Tableau Public. The data you will be loading is a comma-separated value, or CSV file. This is just a text file where all of the values on each row are separated by commas. The file you downloaded is a zipped file, so you need to extract the CSV file from it. First, we are going to walk through the process for those using their own PC. The file, named SSA statedata.zip, is most likely in your Downloads folder. For this example, I'm assuming it is on your desktop, but it's only to make it easier to follow. You can drag the file onto your desktop from your Downloads folder to follow along. Double-click on the zip file on your desktop. This will open the archive in a file view as shown here. Drag the CSV file onto the desktop. If instead you're using a Mac, it's even easier. Using the Finder tool, locate the CSV file in your Downloads folder. Then, double-click on the file, and your Mac will extract the file for you. The CSV file is now also in your Downloads folder. If you just installed Tableau Public, it's already open on your desktop. Or, if you're using a lab computer and just signed up, it's open in your browser. However, if you signed up for Tableau Public previously, and it's not currently open, how you get started depends on whether you're using your own laptop or a lab computer. We'll run through getting started on your own computer first. Since you installed Tableau Public on your laptop, you should see an icon for you on your desktop as shown here. Double-click on that icon to open Tableau. The initial interface will look like the screen shown here. To tell a data story, you need to load some data. Since the data file you downloaded from Canvas is a comma-separated value file, or CSV file for short, click the Text File option in the Connect panel on the left side of the screen. You will be prompted for the data file. Select it from your Downloads folder. It may take a minute to load. There are over 6 million rows of data. The data will open in the Data Source tab as shown here. You're ready to get started. Now let's get the students using a lab computer started. If you're on a lab computer, you will be using the web-based version of Tableau Public, so the process for getting started is slightly different. Go to the Tableau Public webpage using the link in Canvas, and then click the Sign In button. The URL is also shown here on the screen. You will be prompted for the email address and password you used to create your Tableau Public account. After entering your info, click the Sign In button. In the next screen that appears, click the Create option in the menu at the top and select Web Authoring. A new Tableau workbook will open in your browser and prompt you for data. Drag the SSA statedata.csv file from your Downloads folder onto the Connect to Data panel. Depending on the speed of your internet connection, this may take a couple minutes to load. You'll see a progress bar. It's loading over 300 megabytes of data. When finished loading, your data will appear in the Data Source tab. Click the Update Now button to see a preview of your data. Now you have data, so let's take a look at it. When you loaded the data, Tableau made a guess as to the data type for each column based on the values in that column. In the header for each column, Tableau added a small icon to indicate the data type it selected. For the State Code column, which has a 2-digit code for the state, Tableau added a small globe to indicate this is spatial data that can be mapped. You also see that it added the same icon in a column with the state name. In the count column, which tells us how many people were born in a particular state, in a particular year, with a particular name, and of a particular gender, applied for a Social Security card. Tableau added a hash mark icon to indicate this is numeric data. The name column contains text, so Tableau added an icon that says ABC to indicate this is textual information, or what computer programmers and Tableau refer to as a string. That may seem like an odd name for text data, but it means a string of characters. There is one field where Tableau made an incorrect choice. Let's take a closer look at the gender column. This column contains one of two values, either an F for female or an M for male. Since Tableau guesses the data type based on only a sample of the data at the start of the file, and the Social Security Administration's data lists all of the women's names first, the sample that Tableau saw always contained an F in the gender column. This led Tableau to interpret this as meaning false and decided this is a Boolean field, so it has an icon T/F. Boolean fields are always either true or false. If you wonder why these are called Boolean fields, they're named after a mathematician named George Boole, but I digress. We need to change the data type for the gender field to instead be a string field. Fortunately, this is easy to change. Click on the data type icon for the gender field. This will display a small pop-up dialog, and you'll see Boolean is currently checked. Instead, click on the string option. This may take a minute to update, then you'll be done loading the data. We'll now take a brief tour of the Tableau interface and then set a configuration setting that's needed if you're using a Mac. If you want to look at your data again later, just click on the Data Source tab in the lower left-hand corner of the Tableau interface, and you'll return to this screen. We'll now take a brief tour of the Tableau interface. Click on the tab labeled Sheet 1. The first thing you'll notice is the data pane on the left-hand side of the screen. It lists all of the fields in your data. Next to each field is its data type. On the top of the data pane is the name of your data source. If you included multiple data sources, either files as we have done, or tables from a relational database, you could join them together in the data source pane. However, if you have not previously worked with databases, joins can be a bit confusing, so we're not going to explore that. There is a lot you can do in Tableau working with a single data file. And in a corporate environment, it's common for a database administrator to create a view that the data analysts can then access. You may have noticed the fields are listed in alphabetical order, but you may have also noticed that's not entirely true. There's a field with the rather odd name of Field Names that's in italics and is out of order. Right after that field, there's a really thin gray line, and then the list starts all over again in alphabetical order. That thin line divides the fields that are dimensions and measures, where measures are generally continuous numeric values and dimensions are discrete values. For a moment, let's highlight the dimensions in blue and the measures in gold. When Tableau loaded the data, in addition to figuring out the data type for each field, it also separated your data into dimensions and measures. The measures highlighted in gold are numeric values that can be aggregated. Keep in mind that most visualizations are taking a lot of data and aggregating it into some format that can be more easily understood. If we were working with data about the university, measures could be things like how many points you earned on each assignment, what your GPA is, or how many credit hours you have earned so far. Most measures will have a hash symbol next to them to indicate a numeric data type. When you add measures to a chart, Tableau will make a guess as to how you want to aggregate that data, but of course, you can always override Tableau's guess. The dimensions highlighted in blue are descriptive data. This will include any text fields, but also includes geospatial data, such as the state code and the state name, as well as a gender field, which is a Boolean field. Numeric data are usually classified as measures, and although the SSA_year field is numeric data, Tableau has identified this as a dimension. One last thing to note about the data pane. The Measures Names field. It's both italicized and alphabetically out of order. This is because this field is generated by Tableau. It's not actually a field in your data. Any generated fields will be in italics and will be listed at the end of the dimension or measure sections. In the measures, there's a generated field named count that you will often use in your visualizations. This field is always named after the data source and allows you to count rows in your data that match other criteria in your chart. There are also generated measures for latitude and longitude, but generated based on what? Any geographic dimension. In your data, you have 2-digit state codes as geographic dimensions. Any measure can easily be converted into a dimension, and any numeric dimension can be converted into a measure. You could also create a calculated field to assign numeric values to a dimension and use that as a measure. Let's take a look at the rest of the interface. The large blank area where your chart will be displayed is known as the view. Most of the interface is drag and drop, while you'll be pulling fields from the data pane onto what Tableau calls shelves. The two shelves you'll use in every visualization are the column shelf and the row shelf. These are located just above the view. These may seem like odd names, but if you're wanting to display tabular data, fields in the column shelf would be columns in the table, and fields in the row shelf would be rows in the table. However, most people don't bother to use a visualization tool to show tabular data. If you instead imagine a simple bar chart, you can think of the fields added to the column shelf as defining the bars in the chart. If you tend to think of charts in terms of an x-axis and a y-axis, the column shelf defines the x-axis. If you are creating a bar chart with vertical bars, this would generally be a dimension field. In our bar chart, the row shelf would define the y-axis, or in other words, how tall each bar is. There are a couple of other features we need to point out, then you'll be ready to start the exercise. Another feature you'll use in a lot of your charts is the marks card. Again, it's a seemingly funny name, but Tableau thinks of every data point on a chart as a mark, and the marks card defines how each data point is displayed. The best way to explain this is with a visual. Hopefully you've already watched the video snippet with Hans Rosling. If you haven't watched it, you should. Although Hans passed away, people still discuss his TED Talk at conferences, and many people in data analysis describe it as opening our eyes to the great potential of data visualization. Although it was not created with Tableau, even Tableau considers his presentation to be one of the 5 most influential visualizations of all time. Anyways, we'll use it to explain the marks card and the remaining shelves. In Hans's presentation, family size was on the x-axis, which is columns in Tableau, and life expectancy was on the y-axis, which is rows in Tableau. Each country was a bubble in his chart, and countries in the same region were the same color, so the regions of the world would be dragged onto the color shelf on the marks card. In the picture shown here, the African countries are blue, and the Asian countries are red. The size of each bubble is based on the country's population, so the population field would be dragged onto the size shelf on the marks card. This visual is of 2008 data, so China is in red is the largest bubble, and India in light blue was the second largest. In Hans's visualization, the annotations of the countries are external to the bubbles. In Tableau, the country name field would be dragged onto the text shelf on the marks card. In Tableau, the title would be displayed inside of the bubble, assuming there was enough space for it. In some cases, you may want to provide more details about each data point. The fields with additional details can be dragged onto the tooltip shelf on the marks card. In Hans's visualization, you might want to include income, education, GDP, or some other fields as details for each country's bubble. The last 2 controls on the marks card I use less frequently. The drop-down at the top of the marks card lets you decide what symbols should be used for each data point. This can be handy in some more advanced visualizations. Similarly, the detail shelf is not frequently used directly. Moving on from the marks card. The filter shelf can be used to filter out values you don't want in your chart. Possibly if there's a small rich country that was an outlier in Hans's visualization, that would cause the main point to be lost. In that case, the country field could be dragged to the filter shelf and that country could be filtered out. Since any filtered out data should be disclosed, by default, if you export a visualization from Tableau, it'll include an annotation as to the filters applied. The last shelf, named Pages, is interesting and it allows you to create animations. Recall that in Hans's visualization, the bubbles move to show the changes from year to year. To do the same in Tableau, you would drag the year field to the Pages shelf. Tableau automatically adds player controls to the chart that allow you to play the animation forward or backwards and control the speed. There is one configuration setting you need to make if you're using a Mac. Note, this only applies if you are using a Mac. Click on the Help option on the main menu. From the menu that appears, select Settings and Performance. From the submenu that appears, uncheck the option named Enable Accelerated Graphics. Despite the name of that option, if you leave that option checked on a Mac, the interface will become unbearably slow. The last step is to save your workbook so it'll be there when you start the exercise. Select the File option from the main menu. From the menu that appears, select the Save option. A file dialog will appear and prompt you for a file name. By default, it'll use the My Tableau repository directory that was created when you installed Tableau Public. Use that default directory and name the file Exploring Names. When you return to Tableau Public, there will now be a tile on that initial screen with the name of your file. You will just click on that tile to start the exercise.